Alright, today I am going to my EaS reflections, if all Etch-a-Sketch reflections are isometries. So first thing we're going to do again, come over, look at the definition. So a reflection, a definition is given a mirror line, draw a new line that is perpendicular to the mirror line through the point to be reflected. The image is the point on the other side of the mirror line from the original point and is the same distance from the mirror line as the original point is to the mirror line. So basically what it's saying is if you have something on this side, it's got to be the same distance away on this side, and it's got to all equal up. So first thing we're going to do is we're going to start with our initial points of 0, 0, and 0, 5. So go over to the graph. 0, 0 is here, 0, 5, 1, 2, 3, 4, 5. 0, 5 is going to be right there. So then the next thing we want to do is, so we have our line here, and it's going to be y is equal to 2x. That's the slope of our line. So what we want to do is make a perpendicular line to this one and find out the first, we want to find out the slope of this line, and then second we want to see if when this point hits this line, if it's on this line, and then also if it is on this line, how far, and when we reflect it over the line, where it's going to be, what point it's going to be at, and if it's the same distance away from the origin and this other line and this point. So this point and this point being away, and then they're reflected in this point to the line away. We got to make sure that they're all the same. So in order to find the slope of this line, all you do, because we know this is a 90, so we know these lines are perpendicular, so all you have to do, so this is our original one, so then our new slope would be y equals negative 1 over half x, and then we're going to do plus 5 because mx plus b, and our b is our slope, or our b is our y where it crosses, and we cross at 5. We cross the y-axis at 5. So that's where we get the 5 from. The 1 over half x is just the exact opposite of this 2. We just flip it, and so that is how we get the slope of that line. So the next thing we want to do is we want to figure out how far away it is from this point to this point using these two, or using the two equations. And for this example, it works out really nice because we can just go down 1 to the right 2, and that is where this point falls on both. That's where the two lines meet. Is that it actually be 2, 4 would be the point here. So this point is gonna be 2, 4, and that's where this one falls. And then to see where this line keeps going, to see the reflection, so we went down 1 to the right 2. We're going to do that again to find out where the next spot is. So we go down 1 to the right 2, and so then our new point is going to be at 1, 2, 3, 4, 1, 2, 3, which then if we look at it, so now we figure out, so now that we got our 2 points, so this is 0, 5. So 0, 5 to 2, 4, 0, 5 to 2, 4, it is 1, 2, 3 away. So our distance is 3, and from 2 to 4 to 4 to 3, our distance is 1, 2, 3. So that way we're good. Our distance is good on that one. And then so our distances between our 2 points is 3 and 3. So that's good. That's what we want. But our initial distance from our center point to our 0, 5 is going to be 5. And then we have to find out from this new point how far away this is from the origin in order for it to work for every reflection. So what we do to do that is we just count how far away it is, and that's just good. So 1, 2, 3, 4, 5, 6, 7. So this whole distance here is 7 away, and our initial distance was 5. So we figure out that 5 is not equal to 7, and by doing that, just by seeing that 5 is not equal to 7, we see that all reflections do not work as isometries. So we can use this example then to break every other, just say that not all reflections are isometries.